Hello and welcome. We're going to go over this problem, remove outermost parentheses today. And we're going to use umpire process to do so. So let's get started. So the problem statement is a valid parentheses string is either empty, um, this this empty parentheses or this open parentheses plus a plus this and put on the a plus actually it's a plus a plus this end parentheses or a plus b where a and b are valid parentheses strings and plus represents a string concatenation. For example, the empty parentheses, the parentheses inside the quotes, and this parentheses expression and this parentheses expression are valid parentheses strings. A valid parentheses string S is primitive if it is non-empty and there does not exist a way to split it into S equals A plus B with A and B non-empty valid parentheses strings. Given up a valid parentheses string, consider its primitive decomposition as P plus P1 plus P2 plus P dot 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 PK or PI are primitive valid parentheses strings. Return S after removing the outermost parentheses of every primitive string in the primitive decomposition of S. So let's just go through an example to understand better what this stuff is saying. So the input is this parentheses string. Then we're just removing the outermost parentheses of each valid parentheses subset. So the valid parentheses subset is this parentheses pair and this parentheses pair, and it's encased in this parentheses right here, so outermost parentheses. So we just remove that and we get these two parentheses here. And then the second parentheses pair or the second parentheses is there's a valid parentheses on the inside of this outermost parentheses. So we just remove the outermost parentheses and we get just a regular old parentheses back. So so a valid parentheses string is primitive, it's not empty, and there just not exists a way to split it. So that's um this is a primitive and this is a primitive, but it's encased in this parentheses um pair. So it's just removed. This outer parentheses is removed, and then for the second decomposition, we have this inner parentheses preserved and this outer parentheses is removed, and so we get this output. So the input string, this is with primitive decomposition, this and thus. So after removing the outer parentheses of each part, we get this double parentheses plus this single parentheses, and we get these three parentheses in sequence. So another example is this parentheses string, a valid parentheses. So um, we have decomposition, this parentheses sequence, this parentheses, and this parentheses sequence. And after removing the outer parentheses of each of these three parts, then we have this double parentheses, this parentheses, and then this pair of parentheses. So we get this in conclusion. So this is the outputs. And if we have, say, just two parenthesis pairs, the decomposition is these this parentheses and this parentheses, and then we remove the outer parentheses of each of these, and then we get nothing. So we get the empty string back. So now that we have an understanding of this problem, we just will write down a little bit about what the inputs and outputs are. The input is decomposition of parentheses, primitive parentheses, and then the output is parentheses with outermost parentheses with each decomposition. Okay, so now that we understand what's going on, so let's match this. This matches to a list manipulation problem. And with counts, we need to preserve a count to be able to uh, figure out what open and closed parentheses are listed. And then our plan is just going to um, we're going to initialize input string or results, which is just an array. And then we're going to initialize count. And then we're going to iterate or go loop through string s, and then if character is equal to parentheses, then we're going to the open parentheses, then we're going to increase count by 1. And then if count is greater than 1, preserve um, or I should say append open parentheses, which skips outermost parentheses. And then if character equals this close parentheses, we're going to decrease count by 1. And then if count is greater than 0, append close parentheses. And then we're going to dot join the results and outputs. So let's implement this plan. So we first have results, and then we have for character in string, if character equals this open parentheses, then we want to increase the count by 1. Oh wait, we have to initialize count first. And then if count is greater than 1, then we want to append the result what character is, and then else in the case where character is a closed parentheses, we want to decrement the count by 1, and then if count is greater than 0, then we want to append the results of character, which is the closed parentheses, and then we want to print the results. There's a join of the array. Okay, so we can run this code. Okay, we got it accepted. Oh, we got to accept it. So this is a solution to this remove outermost parentheses problem. So let's look at a review of this problem. So we're going to step through this code. So we want to remove outer parentheses. So we have this parentheses description, which is a decomposition of this first sequence and this second sequence. So our result is going to be an empty array, and then we initialize count, and then we have x for string input. So we x, if x is an open parentheses, which it is, we're going to increment the count, and if count is greater than 1, which it isn't, then we skip back up to the for loop, and then we go to the second um, string element, and then it's an open parentheses, so we increment count as 1, and since count is greater than 1, then we append the result. And then we skip to the next element of the for loop, which is a close parentheses, and then we hit the else we count decrement. And then if count is greater than 0, so which it is, then we append the results. So we continue on the for loop, and then we have an open parentheses, and then we increment the counts, and count is greater than 1, so we append the results. And then we continue, and then we have a close parentheses, we decrement the count, and we count is greater than 0, so we append the results. And then the next is an open parentheses. So count is let me go back. Okay, so we append the results. So we go back to the loop, and then it's the next one is an open parentheses. So um, oh no, the next one is a close parentheses. So we decrement the count, so we're back to 0. And then we go in again, and then x is open parentheses, and then we increment the count, and count is not greater than 0, so we don't append the results. So we go continue, and then we have another open parentheses, and we increment the count. The count is greater than 0, so we append the results of open parentheses, and then we continue. We're going to get a closed parentheses now, and we decrement the count, and the count is greater than 0, so we append the results. And then it's so the last is decrementing the count, because um, it's a closed parentheses, and the count is not greater than 0, so we don't append the result. So we're done, and we join the results, and then we get this return value. So that's the solution of this review. So now we're going to evaluate this problem. So the evaluation is an ON time complexity solution and an ON space complexity solution. Since we use result to hold the extra space, and we're going to be at most holding S members, or S length S members, and ON is also this the single for loop which goes through the entire string, so that's ON time complexity. So now that we're done with this problem, we can exit here. So thanks for listening.